Have you ever just stopped and looked at a garden? I mean, it seems so calm and peaceful, right? But what if I told you there's a secret mission happening all around you, right under our noses? Every single flower, every bee, they're all part of this incredible plan to create new life.
And this mission? It's the reason we have apples, strawberries, and so many of the foods we absolutely love. It's all thanks to a process called pollination. So come on, let's join the mission and figure out what this is all about.
All right, first things first, mission basics. What even is pollination?
Yeah, what exactly is this all-important secret mission we're talking about?
Okay, so here's the secret sauce. Pollination is simply moving these tiny grains of pollen from the male part of a flower, that's the anther, over to the female part, the stigma. That's it. But that one little hop, it is the absolute first step for a plant to create a seed. No hop, no seed. So to really get how this works, you've got to meet the key players in this whole operation. Okay, first up, we have the anther. You can think of this as the pollen launch pad. This is where all the pollen is made and stored. And this stuff isn't just random dust, you know? Every single grain is like a tiny little data packet, carrying half the genetic blueprint for a whole new plant. And our second key player is the stigma. This is the pollen's landing zone. It's often kind of sticky or feathery, which is just perfectly designed to catch any pollen that comes its way. Once the pollen lands here, the mission can move on to the next stage. So how does the pollen actually make that journey from the launch pad to the landing zone? Well, flowers basically have two main strategies in their playbook to get the mission done. Strategy number one is called self-pollination. This is when pollen moves from the anther to the stigma of the exact same flower, or maybe another flower on the same plant. The plant basically handles the whole mission all by itself. Then there's strategy number two, and this is where things get really interesting. It's called cross-pollination. This is when pollen travels from a flower on one plant to the stigma of a flower on a completely different plant. Now, self-pollination is reliable, for sure, but cross-pollination, that's where the real magic happens. Mixing genes from two different plants creates stronger, more adaptable offspring. It's like a team-up. But for that to happen, plants need a little help. They need agents to carry the pollen for them. And that brings us to the mission's special agents. These are the helpers that make cross-pollination possible. So the most famous helpers are insects. And wow, flowers have evolved some brilliant strategies to get their attention. They use these brightly colored petals like giant billboards. They produce sweet scents as an invitation. And they offer a high-energy, sugary drink called nectar as a reward. Even their pollen is designed to be sticky, so it easily latches right onto any visitor. And just look at these expert agents in action. As bees and butterflies fly from flower to flower, sipping that nectar, they get unintentionally covered in this pollen. When they visit the next flower, some of that pollen rubs off onto the stigma. And just like that, the mission is complete. It's a perfect partnership. But what if you don't want to rely on insects? Some plants use a completely different agent, the wind. These flowers don't need to be flashy at all. They're often small and dull, with no scent or nectar, because they're not trying to attract anyone. Instead, their whole strategy is to produce enormous quantities of incredibly lightweight pollen, designed to be carried by the slightest breeze. And their stigmas are often large and feathery, like little nets, to catch that pollen from the air. And this method is incredibly important for us. Many of our most crucial food crops, like wheat and corn, are wind-pollinated. They just toss their pollen into the air and let nature do the rest. So you can really see the two different game plans here, right? Insect pollination is all about attraction. You've got the flashy colors, the sweet smells, and a sugary reward. Wind pollination is all about numbers. No flash, just millions of lightweight pollen grains hoping to catch a ride on the breeze. Two totally different solutions to the exact same problem. Okay, so we've met the players, we've learned the strategies, and we've seen the agents. Let's do a quick debrief of the entire mission. When you boil it all down, it comes down to these four simple steps. 1. Pollen is produced on the anther. 2. An agent, like a bee or the wind, carries it away. 3. The pollen lands on the stigma of a compatible flower. And 4. Mission success. The transfer is complete, and the incredible process of creating a new seed can begin. And this is why this secret mission is so important. It's not just about pretty flowers. This fundamental process is the foundation for so much of our food supply and the health of ecosystems all over the world.
Without it, our world would be a very different and much hungrier place.
So, the next time you see a bee buzzing around a flower or watch the wind rustle through a field of wheat, remember the secret mission that's taking place. It makes you think, doesn't it? What would our plates, our gardens, and our landscapes really look like without these tiny, unsung heroes of the plant world?